You guys, you think that that's a correct integral? Well, I have a little problem with that because that's a 3 and that's a 4. Okay, guys, we won't be long today if we get going. How about if I rewrote it this way, if this helps? It's an I. Sorry. What do you think? Well, how are you dealing with that n to the 4th and the I cubed? Well, I rewrote it this way. Oh, that's a good strategy. That's a great strategy. No, it's the limit. I didn't think of that. So if we start with the counter, it's 1 over n to the 4th plus 2 cubed over n to the 4th, because the counter goes I equals 1, then I equals 2, then it's 3 cubed over n to the 4th. Don't multiply it out. Plus 4 cubed. I didn't know. I'm serious about that. I didn't think of doing it that way. I'm looking at it this way, but that's okay. This is a better way to see it, I think. Plus, then it's I cubed over n to the 4th. Now, can you factor anything out of that? Because remember, Riemann sum is the sum of the areas of the rectangles. So I need to have a base and a height. What am I going to factor out? So now I have the limit as n goes to infinity. But if I take n to the, let's take that out. Look at that. And I'm left with 1 plus 2 cubed plus 3 cubed plus 4 cubed, I cubed. I still don't see a base. What does the base usually look like? Remember the delta x? Delta x equals b minus a over n. This is the reason why I did this. This is a homework problem, actually. So think about that now. If delta x is b minus a over n, I don't want to factor an n to the 4th. What do I want to factor out instead? I want something over n. I want 1 over n, don't I? If delta x has an n in it, I don't want an n to the 4th out there. I want to find out what the delta x is. So it's the limit. I could do n to the 3rd, but that's not going to help me. I want the base to be 1 over n, because that's b minus a over n. Then I'm left with 1 cubed, I should have left my cube there, over n cubed plus 2 cubed over n cubed, 3 cubed over n cubed. No, you can't, because they're not the same base. Okay? But how about if I wrote it this way? It's 1 over n, and then this is 1 over n quantity cubed. Now this is looking at our class opener from yesterday. 2 over n quantity cubed plus 3 over n quantity cubed. I over n cubed. I know what delta x is. What's delta x? 1 over n. So b minus... No. Because you're making... What's that?
The limit is 1 over n.
You can't do it that way. You first have to find the sum, and then you take the limit. Because that's 1 over 0 times 1 over 0, and I don't know what that is. Okay, guys? What this means is that the width of my rectangle is getting very tiny. That's 1 over 0, like you said. I'm sorry, 1 over infinity. That's 0. That's right. But these don't ever get there. The rectangles are infinitely thin. So if I take a curve and I put a whole bunch of rectangles together that are infinitely thin, and I put an infinite number of those in there, I will fill this up, won't I? my rectangles are really, really skinny. My board is really, really long. As I make this go to 0, I'll put more in. It's this constant fighting of 0 and infinity, and somebody wins. I get the area under the curve. Okay, Eric, do you know what the answer to this question is? This is the sum of f of x sub I. What is the function? Lori was pretty close, but it's not 1 over x. This is, let's look at the graph. We're going to start where? Are we starting at anything besides 0? Are we starting at anywhere but 0? Is there anything added on to that? No. So the first area, you're going to go over one of those delta x's. What's this x coordinate here? x1, sorry. How many of these delta x's? 1 delta x, which is 1 over n. How do you get to the second coordinate, which I don't have any space there? x2 is 2 times 1 over n. This is the x coordinate. So what is the function? I can't see it because it's underneath the board. F of x is, what are you going to do with that x coordinate? It's x to the what? Third. So it's the integral of x to the third dx. You had the right idea. Where are you going to start? At 0 to 1. What would it look like? Well, what? That's because you we did this yesterday, but they're so confused. Let me see if I can get this down here more. I know that doesn't look like an x value, but it is. Let me get a bigger space here. Okay. Okay, you guys. Eric, put your phone away, please. No, not right now. Okay. This is B. A is 0. So then how big are each of these rectangles going to be on the bottom? That's delta x. How big is it, though? I'm going to take this in complete distance, b minus 0, and divide it into n rectangles. Okay, that's 1 delta x. How do I get to this x coordinate on the first rectangle? Because I have to find f of that value. Well, it's not 1 plus. Where are you starting? X sub 1 is starting at 0. We started at 0 plus we went one of those delta x's. What's x2? Zach, what's x2? This coordinate is starting at 0. And Nick, help him out. How many delta x's? Just counting, it's just geometry. 0 plus 2 delta x's. Well, delta x is b over, let's say b is equal to 1. Then delta x is, guys, this is 1 over n. This is 2 over n. So the x coordinates have n's in them. I just said let's make it 1. Now, I know that b minus a on this one by delta x is 1 over n. Well, that's b minus a over n. Because we started at 0, we don't write the 0 plus this. We just write the 2 over n. So I knew it started at 0, and if the width, if a is 0, then what does b have to be? It has to be 1. You might have to come in and get a little extra help on it. How much time should we spend on it? I don't know. It's one multiple choice question on the exam. Well, there are the 10 multiple choice questions that are sort of repeated from year to year. And those are what give you the 5 on the exam. This might be one of them. But there's no penalty for guessing. Okay, you guys, if you want your conversation, I want to get this done, and then you can chit-chat. Now, this book calls this the evaluation theorem. We know it as a fundamental theorem of calculus. Okay, Alex? Yeah, we're only doing part 1 today. FTC. And you guys know this. Now, it would be interesting, and maybe you're interested in me proving. I did not prove it to you last year, but a Riemann sum is the limit. If n goes to infinity, and I don't like writing this, I equals 1 to n of f of x sub I, delta x sub I. They can all be different widths. I can use all different sample points. Okay, guys? Okay? I want to point out something here. Here, this is, Riemann says, I don't want to write this every single time. So he says, I'm going to make up my own notation. That's a definite integral. But then Riemann, Newton, Leibniz, okay, guys? They must have they're all probably working about the same time in the 1700s. And they kept adding up these rectangles, and they've noticed a pattern that the area under the curve between A and B is actually equal to the antiderivative of your function evaluated at B minus the antiderivative of the function evaluated at A. Now, why would an area be equal to an antiderivative? Did they prove it to you at your college? No, it's kind of it's an interesting proof. Maybe after the exam, if you're interested, or maybe before that, I'll make a little video and prove it. It's still going to take time. It's not an easy proof. I have to use the mean value theorem, and it's a clever proof. I actually, Eric, have to have a collapsing sum. I'm going to add something, take it away. I'm going to create a collapsing sum. That the only thing that lasts when I add everything together is the f of b and the f of a. It's a very interesting little proof. It's hard, but since you know about collapsing sums, I think you guys could do it. So I may make a little video, or we could do it later. Doesn't matter. So how do you know that f really is the antiderivative? You take the derivative. So f prime, I have it written there, is little f. What if you integrate f prime of x dx? What do you get? What does an integral antiderivative of a derivative do? Nick? Okay, everything I say in class is important. It's f of x plus what? C. I know what's on the exam. You guys got to know that. I taught it to you. This question came out of nowhere at a test. And only the students who really understood what they were doing could answer that question. They never, ever talked about it in class. Okay. So we're going to do this problem. I can't make it bigger, but I can rewrite it. I want to integrate from 1 to 3 of e to the x dx. And this one's pretty easy because what's the antiderivative of e to the x? Yeah. How do you write it? You write it this way. And so it's e cubed minus e to the first. So that's what you're going to do in this section. But they're going to add a little more to it. Okay, AJ? They're going to add in interpretation. You will find interpretation on the test, my test on this. And you will find it on the exam. They will say, what is the meaning of this integral? Or what's the meaning of the derivative? Whatever they're doing. Okay, so this is a number. It's called a definite integral. So when you see the a and b there, the integral from a to b is a definite integral. If I don't have the a and b there, it's a function that's called an indefinite integral. And they're both using antiderivatives. Don't forget when you do the indefinite one, because I don't know where that function is. It could be shifted up or down. I have to add c. We did it last year. So if I asked you just integrate e to the x dx, you would say it's e to the x plus c. Now, I'm not sure if I have the right page number, but there is a table of common integrals. You need to know them. I will also give you the handout we had last year about the derivatives and the antiderivatives. Now, there's no chain rule in this assignment, I don't believe. Now, no use of substitutions. You'll know because I'll wear my t-shirt for that day. I'll have to help the plan ahead. Okay, guys, ready? This is the part that's a little bit new for you. This is the interpretation of the integral. This book has excellent problems on interpreting an integral. What does it mean? You need to practice those. And there's almost always 3 things you need on the AP exam, because they'll give you an integral, and they'll give you a time frame, and they're going to give you units. So you have to know what it means. This is easier than that when I do this one. They call this the total change theorem. So here is, let's look at my example here. And this is the total change is the integral of the rate of change. You already knew this, right? What's the integral of f prime? Capital F. And they call it a total change theorem, and I'm going to actually highlight that. The reason being is on some of the AP problems, you'll see a total change. They'll ask you to do this, but I can even think of the problem. I'll see if I can remember to bring it in on Monday because it's one I graded. And they ask you to do this, and it's just so easy because they give you these values in the table, and you have to probably interpret it too. But that's right. I think it says, and interpret what it means. Well, it's the total change in the temperature, or the total change in the price, whatever the application is. But they'll give you more stuff than what we have here. So this is the example. If V of T is the volume of water in a reservoir at time T, then its derivative, and you have to read this carefully, is the rate at which the water flows into the reservoir. Okay, Ori? What's the derivative of it? Yeah. V is your volume. Now, sometimes you guys, they'll call V the rate at which the water flows into the reservoir, and you're going to really want the derivative of that. So you have to read carefully. Now, guys, what does this mean? This means the integral from T1 to T2 of V prime of T dt is equal to V of T2 minus V of T1. What does that mean? It's the total change in the volume. A little more. Total change in the volume is not enough on the exam. Volume between T1 and T2. And we'll divide. Right, and they will ask you, what's the average change? T2 minus T1. That would be correct. Okay? So, those of you who don't like to do homework, do your homework and do these problems because it'll help you on the exam. Okay, distance versus displacement. Last thing, to make sure you be careful, I should be careful because I spelled it wrong, but be careful that you read the question carefully. Okay? Shh, guys? This is displacement. What's the difference between displacement and distance? Eric? Guys, I'm going to ask you to leave. Displacement is where you end up relative to where you started. So if I walk to the main office and come back, what's my displacement? 0. Distance is actually how far you travel. I did travel a distance. So to define distance, you are going to have to integrate from A to B of the absolute value of V of T. And almost always, that's going to be on the calculator part of the exam. Otherwise, you have to know when your function drops below 0. And you have to divide it up into regions. And that's hard. So you know all the material in this section for the most part. The thing that's going to be different is interpreting the integrals. So I highly recommend that you do those. Remember, these are minimal assignments. It may not be enough. You might have to do more. At the University of Minnesota, they expect you to do every problem in a section, which is totally unrealistic, but they expect you to be able to do every problem. Well, it depends on the professor, too, and every professor is different. So that's really what it depends on. Are there questions on homework? I did get my Riemann sum program to work, but sounds